Hello entry students, today we're going to be doing resonance in series. Know that resonance in series is between capacitor and the inductor. Know that when the other one charges, the other one discharges. Capacitor is dependent on electric field while the inductor is independent on magnetic field. Know that in resonance, capacitor will be equal to the inductor. Let's get into it and know that the reactants are also equal. This is the phasor diagram of resonance in series. Impedance will be at minimum. Know that if you throw it in the inductor, it must be, let me fix the light, it must be equal to the capacitor at minimum. Must throw it at both sides and make it equal. The current will be at maximum on both when you draw it on both, since the reactants are equal. And now we're going to look at above resonance, in which we can see that inductor is above. That means the velocity of the inductor will be greater than the velocity of capacitor, same as below. Capacitor here is below, which means the velocity will be greater than of the inductor. And we said that at resonance the velocity is equal, also the reactance. Moving on, we said that as resonant capacitor and inductor are equal, which means their velocity will be equal and even their formula will be equal, guys. And here is the formula and here is the frequency for resonance. We said the reactants are equal, impedance will be equal to resistance at minimum, and I is maximum, current is maximum. Okay, now let's move on to the characteristics at resonance. This is a reactance versus frequency graph. We said the reactants are equal, and this is how you will draw their reactance. And this is the impedance versus frequency graph, in which we said impedance will be at minimum and it will be equal to the resistor. Okay, guys, and this is the current versus frequency graph. This is how you will draw it, and we said current will be at maximum. And this is the voltage versus frequency, in which below voltage of capacitance will be greater and above inductor will be greater, and at resonance they are equal. This is how you will draw the graph. Okay, guys, now let's move on to the questions, in which the question says a coil with the resistance of 15 ohm and the inductor of 128 Henry is connected in series with 58 farads capacitor and the voltage is 100 volts. Okay, we're going to calculate now, and the first thing we calculate is resonant frequency. Okay, let's try it, guys. Let's try it. And first we write the given. Always start with the given, in which the resistor is 15 ohm and inductor is 128 mH. M stands for 10 to the power of negative 3. U stands for 10 to the power of negative 6, and volts is 100 volts, guys. And we know that's the phasor diagram in which everything is equal. Okay, the first question says let's calculate resonant frequency, and guys, this is the formula in 1/2 pi LC. It will be given in the exam. Now let's try to solve the question. Okay, we have 1/2, that is pi, guys, times pi times square root of LC, in which LC is 128 M. I said M stands for 128. I said that M stands for 10 to the power of negative 3 times 10 to the power of negative 3 times C, in which it's 58, and that U, that sign that looks like U, is 58, is the same as 10 to the power of negative 6 times 10 to the power of negative 6, guys. Sorry. this paper is slipping to negative of 6. Okay guys, calculators from there on, calculators from there on. Let's try to calculate it. Let me just fix that. It's 1 over the whole thing, guys. It's 1 over the whole thing. Calculators, let's try to calculate it. What do you guys get? Because I got 58,412. And don't forget to write the symbol heads. And don't forget the symbols, guys. And number 2, we are looking for the inductor reactance. The reactance, in which is 2 pi FL, in which it will be given in the exams. Okay guys, so it's 2 times pi times frequency. What is the frequency? The frequency is the one we got, is 58,412. I made a mistake there. It's not times, it's comma. 58,12. And what is the inductor? Inductor, we were given 128 hertz. 128 times 10. We said that m is the same as 10 to the power of negative 3. Write calculator from there on. Calculator is 2 times pi times 58, comma. There I made a mistake. It's comma. 412 times 128 times 10 to the power of negative 3. Calculators, guys. Calculators, and I get my answer to be 46,978. 978, which is measured in ohms. Remember the sign, guys. Remember your signs. You get marked for your signs in exams. And now the capacitor reactance, in which that is the formula, you will get it in your exam questions. Okay, and in which it's 1 over 2 times pi times the frequency in which we're given. The frequency in which we're given is 58,412. 58,412, and the capacitance will be 58 times 10 to the power of 6. 58 times 10 to the power 10, to the power of negative 6. Right, remember it's over, guys. It's over. It's 1 over that. It's 1 over. Let me just try to make the line longer so that you guys can see clearly. Make the line longer. Okay, that's how it is. Calculators from there on. What do you get? I get 46,978 ohm, in which you guys will see they are equal. We said in resonance the reactants are equal. Capacitor is equal to the inductor reactance in resonance. Even their volume, everything is equal. And now we will look at the impedance, in which we said the impedance will be minimum. It will give us a very small answer. And from the graph we said impedance will be only equal to the resistor. Let's try to see if that is the truth. They're equal, guys. You remember the reactants are equal, therefore it will be 0, and the only thing left will be the resistance, in which the resistance, when we square root it, it will be 15. You see, they are equal. It will be 15. So therefore it is true. Impedance at resonance is equal to the resistor. It is the truth. And their minimum, you see, it's a small number. It's a minimum number. We proved it to be true. And now we will be solving for total current, guys, in which we will get it from this formula. It will be given in exam. So you see that current will be equal to total voltage Vt over impedance, guys. And we got the voltage we were given. The voltage is 100 volts. 100 over the impedance, which is 15. We just solved it. And now we solve 100 divided by 15. What do you guys get? I get 6,667. A. Remember your symbol, guys. Don't forget your symbols. And that is my total. And now we're going to be looking for angle. The angle in which it will be given in your exams. And that is the formula. The formula will be given in your exams. We got 15, and the impedance, we got it to be 15. So the answer will be cos 1. Cos of 1. And now we solve for theta. This is the phase angle, by the way. Cos of 1 will be equal to 0. It's nothing. It's nothing. And now we're going to be looking for the velocity of everything. The velocity, this will be given in the exam, guys. The formula will be given in the exam of the resistance. This is, we're solving for voltage of resistance, in which we got 6,667 times 15, right? Calculators, guys. I get my answer to be 100 volts. 100 volts. Remember your signs, guys. And now we solve for velocity of the inductor, in which is current times the reactance. Inductor reactance. Yeah, it will also be given in the exam. Okay, guys, the current is the same, 6.667. Remember, we're dealing with series, and we got how much? 46,978, in which we'll write it 46,978. And what is the voltage? I get my answer to be 313,202 volts, guys. And now the last one, the voltage of capacitor, in which it will be current times the reactance of capacitor. Current the same in series times the same. Remember, at resonance, the reactants are the same. The reactants are the same at resonance. Remember that, guys. So we say it's 46,978, in which the answer is the same, 313,202, volts, in which we said in resonance inductor is equal to, remember that guys, at resonance inductor is equal to capacitor, everything, their voltage, their reactance, and know that their angle is 0. That is a tip you guys might say. At resonance the voltage is equal, also their reactance are equal, and the angle is 0, even the current is equal. Now we draw the phasor diagram in which is balanced, because everything is equal, it's balanced. In series, know that the inductor go upwards while the capacitor will be below, and we draw the current and resistor, and this is the resonance diagram guys. This is the phasor diagram. Now we are done. Thank you. See you next lesson guys.